students, so after completing the third problem, let's move to the fourth problem on implicit function. So here we have a function and we have to derive one result. Now here we have a variable as a function of other two variables implicitly, and we'll solve this question with the help of the concept of implicit function. So let's see how we get the solution. Now here it is given that x to the power x, y to the power y, z to the power z is equal to c, and we have to show that at x equal to y equal to z, del square z by del x del y is equal to x log ex whole raised to minus 1. Now guys, if you observe the question, then here it's clear that z is a function of x and y. But if you see the question or the given function, then this is a function of x, y and z. So it means if this is a function of x, y and z is again a function of x and y, then it is the implicit function. So guys, I'm going to solve this question with the help of implicit function. Now, as per the implicit function, to get the solution, there are two methods. One is the formula method and one we differentiate each term. So guys, what we'll do is we'll use the second method where I'll differentiate each and every term, or I'll do the differentiation term by term. Now for that, what we'll do is I'll take log on both sides, because you can observe that here I have x in the base as well as in the power. So to bring this x down, I have to take log on both sides. So here we'll say that taking log on both sides, we will get x into log x plus y into log y plus z into log z is equal to log of c. Now guys, we can solve this. So to get the value of del square z by del x del y, first of all I'll differentiate this equation with respect to y. Now guys, to get this solution or to get the value of del square z by del x del y, what we'll do is we'll differentiate this equation with respect to x partially. So here we'll get, now in this first function we have two terms of x, so I'll apply the product rule of derivative. So x will remain as it is, derivative of log x is 1 upon x plus log x as it is, and derivative of x is 1. Next, derivative of y log y is 0 because it does not contain any term of x, plus, now here we have z log z. Now guys, I can't say z is a constant, because since I want del square z by del x del y, then z is a function of x and y. So since it is function of x, I have to differentiate that with respect to x. So first of all, z will remain as it is. For log z, we'll get 1 upon z del z by del x plus log of z as it is, and for z we'll get del z by del x equal to 0. Now we'll take non-del z terms together, del z by del x term together. So here we will get 1 plus log of x plus here we'll get 1. From here we will get log of z, and outside the bracket del z by del x equal to 0. So therefore we can say that the value of del z by del x is equal to, so this will go on the right hand side, will become negative. So minus 1 plus log x upon, this is 1 plus log of z. So guys, here I got the value of del z by del x. Now similarly, I can again differentiate this equation with respect to y partially. So that time we will get value of del z by del y. So guys, by looking at this result, we can easily say that that value will be negative 1 plus log of y upon 1 plus log of z. So here we got two values. Now as we want to find out the value of del square z by del x del y, what we'll do is I'll call this as equation number 1. Now in this equation I got del z by del x term. So what I'll do is I'll differentiate this equation number 1 with respect to y partially, so that here I can get del square z by del y del x. So let's differentiate equation number 1 with respect to y partially. So let's start. So here we'll get 0 because it does not have any y term. We'll differentiate this. So here this first term contains z and z is a function of y. Similarly del z by del x, again it contains y. So here I'll apply UV rule. So guys, here we will get 1 plus log of z as it is into derivative of del z by del x with respect to y, which is del square z by del y del x, plus del z by del x as it is into the derivative of 1 plus log z with respect to y. So for 1 we'll get 0, for log z we'll get 1 upon z del z by del y equal to 0. Now here we have a term del z by del x and del z by del y, and for these two we already got the value. So what we'll do is I'll put these two values over there, and by adjusting all the terms we can get the value of del square z by del y del x. So let's start. So therefore now we'll take this term on the RHS. So we'll get 1 plus log of z into del square z by del y del x equal to, now this minus into minus will become plus, and when it will go on the RHS that will become minus again. So we'll get 1 plus log of x into 1 plus log of y upon z into 1 plus log of z the whole square, and that too negative. Now guys, let's observe the question. So in the question we want value of del square z by del x del y as this, where we'll get this value, or we should get this value at x equal to y equal to z. Now if you observe the answer, that answer contains only x terms. So what we'll do is guys, if x is equal to y equal to z, then I'll put all y and all z as x. So by doing that, here we will get 1 plus log x, which will come here. This will become 1 plus log x. So here I'll say at x equal to y equal to z. So we'll get del square z by del y del x equal to. So guys, this is 1 plus log x. This will become 1 plus log x because I'll put y as x. So we'll get 1 plus log x the whole square. And that will be cancelled with this, because this will also become 1 plus log x the whole square. So I can cancel these three terms. Next, this term will come in the denominator, and that will become minus 1 upon this z will become x, and this is 1 plus log of x. Now here we got the value of del square z by del y del x, but if you observe, then the answer is x into log ex. Now guys, the question is how to create this log ex. So here we already have a term log x. So guys, what I'll do is, here I'll replace this 1 by log e to the base e, because we know the formula that log of a to the base a is 1. Similarly, log of e to the base a is 1. So here we can say it is log e to the base e, and this is log x to the base e. So log e plus log x will become log ex by the property of log a plus log b is equal to log a into b. So here we'll write, so it is equal to, I'll write del square z by del x del y equal to negative 1 upon x as it is in bracket log of e plus log of x, which is equal to negative 1 upon x, and this is log of ex. Then I'll take this negative sign outside, and this will come in numerator as x log of ex inverse. And guys, you can observe that we got the answer. Here we have proved that del square z by del x del y is equal to negative x log ex inverse. So I'm sure that you understood how I got this answer. So guys, keep watching the videos of Ekeeda, because here you can get the knowledge about all engineering subject under one roof. Thank you very much.